Let me share my screen again. Okay, can you see my screen? Okay, just
Yep.
double check.
Yeah.
Okay, great. All right, welcome to the second course, and I'm going to keep what we have left. I think last time I'm trying to give a high level introduction to Bitcoin smart contract, and I think I have like 15 slides or so, and only because it seems very interactive, so I only went through half of it. And please, also this time, I want also to make it interactive. So instead of hearing me here talk, to myself, please feel free to interrupt me anytime if you have a question. Okay. So let's kind of get a reminder of what we have done last time. So basically, I'm talking about, you know, uh, what what is smart contract on Bitcoin, and what are the benefit of doing smart contract on Bitcoin. So I also give a few, I think the most impressive examples of what we have done in terms of smart contract. We had talked about, zero knowledge proof, enabled computation outsourcing. We have talked about, let's say, dark forest type of kind of hidden information games. We have talked about AI machine learning. Also, you can also preserve privacy. So I talk some examples there, but here today I'm going to give more examples. But this time I'm going to show, that it's I'm looking at a different angle. So today, just I will not dive into the detailed code yet. I think that's going to be starting from next time. So this in the rest of this talk, I'm going to show, compare, Bitcoin smart contract versus, so-called other blockchains, which we are competing with. So the first example we look at here is so-called Taproot. This is being hailed as like almost the most impressive breakthrough in the BTC land at least in the last 4 years. So it was first proposed, about 4 years ago in 2018, and then was shipped after some development, which involves hundreds of developers, probably like 3 to 4 years. It was finally merged. It's being. You probably heard about. How many of you heard about this term before? Taproot and probably Taproot upgrade.
Yep.
Anybody? Okay. Yeah, this being hailed as almost like the best, the most impressive breakthrough at least in the BTC land, if not blockchain land. So I'm showing you here, instead of, have hundreds of developers time and across multiple years and doing a lot of tons of research. And then you have a huge, breaking change and then hard fork. So instead of doing all those things, if you want to do it in the real Bitcoin way, you can actually code this. I'm not going to just want to get a sense, not dive into the detail of the code, but you can pretty much code this in a little bit more than maybe 20 some lines of code if you don't count the empty lines. So it's around 20 lines of code. So the good thing about this approach is, you can implement the most complex, feature on the BTC land. If you know how to code it using Bitcoin smart contract, you can actually code it and then deploy it. You don't need breaking changes. You can build all these features on top of Bitcoin. So just on the highest level of what the Taproot is, is a way to, let's say, for example, right? Usually a contract. Let's talk about the smart contract here. It involves a few parties, right? So for example, here, yeah, let's say you have Alice and Bob. They both want to, let's say they are taking a bet, right? They put something there, and then depends on some outcome. For example, they can say, oh, whether the next block hash ends with 0. If it's 0, then Alice wins. If it's Bob, if it's then Bob wins, right? Whoever wins can take the full amount of the bet amount. So this is a general pattern for Bitcoin smart contract, or smart contract in general. Usually a lot of times all the parties involved. So you can either say you put the money here, and then depending on different outcomes, right? Either odd, or let's say the block hash, next block hash, right? Or at a certain height, you can say the block hash is even or odd, you can have different outcomes, right? Then you can decide where the Bitcoin locked up here can go, right? So because all the parties are known in advance. So, one way is to you actually go through the smart contract, right? So the Taproot idea is, since all the parties will already know each other, and if we're being honest, right, though we don't actually have to publish this contract on chain. So what we can do is we have almost like a shortcut. If everybody agrees on outcome, we can pretty much just sign it. Think about this like a multi-sig here. So you both need to sign. So Alice and Bob, if they're honest, right, and let's say, after they see the next block is odd, right, so Alice wins. And so if Bob is cooperating, they can both sign and then just get the money to Bob. They don't need this whole complex contract part, right? So because this has two drawbacks, right? If you run the normal contract, first of all, it's going to be a little bit big than at least the normal, pay to public key hash type of contract, right? So you are going to save transaction fee. Second of all, it's also good for privacy, right? Because instead of pushing, publishing the contract on chain, which everybody can see, right? Even though you can see the address, you don't know who, but it's still like, it will be better for privacy if you can hide even this contract details. So by signing this, you can also hide the whatever is going on in the contract. So two benefits, right? Privacy and also the transaction cost. So, this is, I think it's a good idea, but, instead of doing the multi-year, hundreds of developers and huge breaking changes and, going back and forth, instead of doing 4 years, you can pretty much just code this. If you use Bitcoin smart contract, there's no breaking change. You can implement this on top of original Bitcoin. I think this is going to be a recurring theme. So basically a lot of features other people think that's impossible to do on Bitcoin today. And either they change Bitcoin or they launch some new blockchain, from scratch. So the basic idea here, hopefully I can convince you today is, a lot of times, I wouldn't say all the times, a lot of times, even the most sophisticated feature on other blockchains, they can actually be implemented at the smart contract level without any breaking changes to Bitcoin. So I think I pause a little bit here. Any comments, questions so far, either Taproot or as a whole about Bitcoin smart contract? Anyone? Taproot. Okay, seems good. So there's no comment. Let's keep moving. So I just talk about the Taproot. I mean, the other related, feature you probably heard about. How many people heard about this graph root thing? Heard about this term? May not be. You don't have to know the details.
No,
Anybody?
not heard of it.
Okay. Yeah, this is also proposed by the same guy, Greg Maxwell. So he kind of invented the Taproot, which is the largest upgrade, since StackRate in 2018, right? So they proposed the next kind of an improved version of Taproot called GraphRoot. So we're gonna go to the detail, but the short answer is, summary is, they're going to, in the next biggest upgrade, I think you can probably see a lot of marketing and PR coming in the next few years. So they probably will take a few years to have this huge upgrade, which they claim will push BTC to the dominant, at least like a major smart contract platform. So what I'm showing here is, you don't have to wait for a few years and then hundreds of developers to develop this thing. You can already code this up in Script, in Bitcoin smart contract today. I think I released even a few examples there. So you don't have to wait for a few years. You can do it today. So that's another thing. I think it was highlights the benefit of doing all the upgrade in the smart contract way. You can do it on top of Bitcoin. You don't have to go through all this breaking changes. They probably need another huge upgrade for this, just for this. anytime they have good ideas, they're going to, change the protocol pretty much. So here is good. Another example, you don't have to change the protocol. You can just be smart and code it in smart contract. So this one also have been, merged in the Taproot upgrade. So I think just want to get a sense. How many people heard about this term? Schnorr signature? Anyone?
Yeah.
Yeah, this kind of like being hailed as another, huge breakthrough, right? Not only in BTC land, but in many other blockchains. BCH, probably some other blockchains that try to reuse the Bitcoin, the ECDS, so-called ECDS keys. So right now, in Bitcoin, our Bitcoin, we use a different signature scheme, right? Which has been around since the first one in 2009, called ECDSA, right? Digital signature. So this Schnorr signature is an alternative digital signature algorithm that has been hailed by other blockchains as like almost like the better version of ECDSA. Let's even given them that. I think I'm not even sure that's true, but even assuming, okay, this is the better, which I personally don't think so. I don't have to go to details here, but the short answer, the summary here is, even assuming this is better, you don't need breaking changes to add this into Bitcoin. Again, I'm showing this, they have another BIP. This has been merged in the Taproot upgrade, and they have this as like next big breakthrough. But again, the same story here. Instead of using breaking changes and change the consensus layer, you can just code this. If you really want to use Schnorr signature, the benefit, for example, you can aggregate the signatures more easily, right? But ECDSA, you can also aggregate it. So that doesn't make it better. But if you really want to do it, you can also code in Bitcoin smart contract. You don't need breaking changes and wait for a few years to implement this. So this is another example, BTC land. Any question here, Schnorr?
Yeah, I have a question. So
yeah, go ahead.
From what I know, so the BTC community does not want like to introduce modern smart contracts because they believe that it's not so secure, and their arguments often linked to the Ethereum smart contracts, which obviously has a lot of security flaws. So we heard a lot of times that some security problems with Ethereum smart contracts found, and some project lost a lot of money because of it. So how secure is BSV smart contracts, and how it was tested, audited, etc.?
Okay, yeah, wonderful question. So you pretty much have a trade-off here, right? So one, you have a two end of the spectrum. On one end, if you want to be secure, then what do? You disable all the smart contract capability, which is kind of like a BTC is doing, right? So then it's kind of secure because you can only do simple payment. It's pretty secure, right? On the other hand, you want to have the so-called full programmability exposed to the users, and then the problem is, you can get all kinds of hacks, right? Which has been happening, if not every day, probably every week, right? You heard about some smart contract get exploited. So we kind of like I would say like somewhere in between, because first of all, at this consensus layer, Bitcoin's consensus layer, there's no let's say fundamental hackable things there, right? There's no it's no software. If we assume that no software is solid, all the smart contract is building on top. It's again like any other kind of software, because at the end of the day, it's still a software, right? You can call it contract, but it's just software run by the miners, checked by the miners. So if you want not to be hacked, of course you want to code it in a way that's no, you want to make sure there's no bug, right? It's like any other software. For example, we're using Zoom or using browser. How do you make sure it doesn't crash or have problem? You want to go through all the software engineering practice to make it, to rule out as many bugs as possible. So that's one thing, is an engineering issue. So basically, it's like any other piece of code. You have to make sure the code is, the logic is correct, to cover all the edge cases. So you apply all the normal software development best practice. That's number one. And number two, I think, which is more fundamental, why Bitcoin smart contract is inherently more secure. So I think I'm going to cover more details when we get into details, but on the high level is so-called functional or stateless, right? So I think let's go back to the, one of the few slides, first slides we showed, right? So Bitcoin smart contract is so-called, pure function, meaning it doesn't have, inherently doesn't have state. It doesn't rely on external state. And because it's pure, it's stateless. So it's almost like a math function, right? So for example, if you're doing square, right? If you square 9, you get 81. It doesn't matter when you do it or how you do it or where you do it, right? Versus Ethereum, they have a global state smart contract. So for example, if you run one smart contract correct, it succeeds today. If you run it 1 hour later, you may not, right? Because for example, if you transfer, the smart contract is transferring money, right? Is Alice transfer 1 ether to Bob, and Alice only has 1 ether to begin with. So after the first call, it succeeds. But if you call the same thing again, it will fail, right? But versus for Bitcoin, because it's so-called, almost like functional paradigm for people who have heard about the functional programming, right? It's just pure mathematical function. So if you have the input, same input, it's going to give you the same output anytime. So this also means it's much easier to make it correct because you can always test it locally. If you pass it locally, it's going to be accepted by the miners because you are running the same function. Actually, that's also what, when we go to the testing phase of the smart contract, you will notice the big difference is to test Bitcoin smart contract, you don't need a blockchain to test it. You don't need to even rest test local blockchain. For Ethereum or other blockchain platform, right? When you test blockchain, test the smart contract, you have to launch it like either locally or send it to testnet or even mainnet. For us, it's just a math function, it's stateless. So it's much, much more secure because if you test it locally, it's almost, I wouldn't say 100%, it's almost surely the miners going also to accept it because it's just it's running the same function. There's no state. Does this help, address some of the concerns? Yeah, that's a fundamental difference.
This is a great answer, thanks.
Yeah, good question. Yeah. Any other comments, questions? Okay, if not, I can keep going. So far we look at BTC land. I think let's move a little bit to its cousin, BCH. I think for people who have been around here for quite a while. So when BCH first tried to split, it's one of the so-called technical, argument is, hey, we want to do the digital signature. But so for people who have not known yet, so in Bitcoin you have the instruction to check the signature, but that has a, I wouldn't say limitation, but you can only, for digital signature, usually you can check the validity against any signed message, right? But in Bitcoin, the native Bitcoin opcode is such that when you check the signature can only be the transaction. So that means if you want to sign some other data, right? Like for example, people want to say, I want to import some external data, let's say price feed, or even say weather, right? You want to have some kind of a insurance contract. You want to know whether your flight is delayed or whether the weather has been good in this summer or what's the price for gold today, right? If you want to settle some kind of contract. But Bitcoin, that's impossible to know, right? So if you want to import external data into the smart contract, so there's only one way to do it, the so-called trusted oracle, right? But then that means the oracle has to sign it. But the argument is back then is, in Bitcoin you cannot sign, external information. You only can sign the transaction, which is not good enough. So that's one argument. They're saying, hey, that's why we have to introduce this breaking change, having this opcode called op data seek verify, op DSV, or some people call it check data seek. And then similarly, BTC land also have this, check signature from stack. So it's pretty much the same opcode. And they have been arguing Bitcoin, the original Bitcoin cannot do this. So actually not, right? So if you think about the digital signature, it's just algorithm, deterministic algorithm. Involves some kind of elliptic curve operations. You have point addition or you have a scalar multiplication. And then we have implement elliptic curve using Bitcoin smart contract. And then based on this primitive libraries, so you can very easily implement arbitrary kind of a digital signature, at least elliptic curve. So as an example here, we have implemented so-called ECDSA, but within smart contract. So you don't have to, BTC land, you have this opcode, or in the BCH land, you have this opcode. So all of this can be done by writing some smart contract. You don't need breaking changes. Any comments here? Questions? So I think I even showed this to the BCH people. So they just, but their argument again is, oh, it's bigger. It's not one opcode. But here's the thing, right? If it's just verifying the signature, it doesn't matter if you're using introduce one new opcode, or if you're coding smart contract, the miner is going to do the same type of work, right? Because it's running at the CPU level, it's running the same algorithm. And also when you put in the opcode, put in the Bitcoin smart contract, you can have all kinds of ways to optimize as well. So it's not, so it's actually cheaper if you want to do it in Bitcoin, in smart contract way. Okay. So, we just talk about different competing Bitcoin forks, and then let's go into some other completely, independent blockchains then. So the number one I want to talk about here is Zcash. So I think most people have heard about it. How many of you heard about this blockchain before? Zcash?
Yeah, obviously I've heard.
Yeah.
Okay. Yeah, it's been around for quite a while. So, okay. Yeah, it's so-called one of the so-called privacy, which I would call it anonymity-oriented cryptocurrency. So it's based on this technology, which I think I covered a little bit last time, called zero-knowledge proof. So basically, it's pretty much like a Bitcoin, but you can hide all the sender receiver information, but also you can hide the amount of coins you are transferring. So it's supposed to be, add more privacy. So using this kind of more math, very advanced cryptography called zero-knowledge proof, specifically called Zcash Schnorr. And this stack has been, thought of the most, innovative either cryptography out there, which is very popular, hot right now. And we have actually implemented Zcash Schnorr inside Bitcoin smart contract. So this is similar to, this is just give you a sense, not diving into detail, but the short story here is instead of even launching the whole blockchain, you can build this Zcash type of application, but on top of Bitcoin, you can have like a smart contract saying, hey, this is I would call it the Zcash tokens or whatnot. You can run in the whole blockchain, almost like as a sub blockchain, but running on top of Bitcoin. And then because we have implemented Zcash stack, the type of zero-knowledge proof, you can also achieve within this smart contract. You can also think about, you can also have, for example, you have Zcash tokens contract. You can implement this using our tools, and then when you have sender, receivers, and amount, you can also hide off them, and then make sure the transfer logic, transaction logic is still being maintained. Nobody's creating money out of thin air, or nobody's spending money they don't have. So this is another example of, not only you don't have to introduce new opcode, but a lot of time you don't have to launch the full blockchain. You can use smart contract capability to, get the features, implement the features you desire on top of Bitcoin. Does this make sense so far? Anyone?
Yep.
Okay,
Sounds
sounds good. Okay, sounds good. Let's show another example. So how many people heard about this term roll up? Just want to get a sense. Roll up?
Yep. Yes.
Okay.
Ethereum.
Yes.
Sort of
So
sidechain.
yes, yes. So this usually when people talk about roll up, it's associated with other blockchains such as Ethereum, right? Because this is being hailed, by Vitalik himself as the ultimate way to scale Ethereum, right? So they use this roll up idea. Roll up, they have two variants. One is so-called ZK roll up. There's another one is called opportunistic. But we focus on the ZK roll up because this has been hailed as almost like the holy grail of Ethereum scalability. The basic idea, what is the basic idea? Is let's say you have a smart contract, right? A smart contract you can think of even it's almost like a state machine. So you have a state one, and then you have different transactions coming in. Then you run your transition function. You transition to the new state. Right? So you check all the logic is correct. On Ethereum, the miners, Ethereum, well, now it's called validators. But anyway, so it uses uses the same technology as Zcash, called using zk Schnorr. So zk Schnorr has two properties. One is so-called privacy, right? Because you can prove something is true without telling me what is the secret. So the other side is they called succinct. So basically what it means is you can, let's say if Alice, compute some function, let's say f of x, and then Bob wants to check whether the result is correct, right? Yes, Bob has, the naive way would be just Bob take the function and run it on X, right? But what if Bob is a low power device, let's say a smartphone or browser, and the F is super complex, maybe takes hundreds of machine hours, but Bob doesn't want to do that. Right? So using the so-called ZK technology, you can generate a proof. When you have the calculate function, you can also attach a proof, and then if Bob take the proof, he can verify it within like tens of minutes, just 10 milliseconds for sure. For example, it's very fast. You don't have to run the whole thing. So it may take a year to compute, but using ZK, you can verify it within let's say 10 milliseconds. So that's how they use this technology to scale, right? So instead of having, let's say, for example, you have 10,000, you have 1,000 transactions here. If you apply run all these transactions, it's going to change the state from state one to state two. So instead of miners verify all the 1,000 transactions, you pretty much generate proof saying all these transactions are valid, and then you submit on chain only the final proof. This proof says if it's valid, this proof is verified, that means all the 1,000 transactions is good. So instead of running 10,000 transactions, you only check the one simple proof. So that's why they want to scale, using so-called layer 2 or ZK rollup ideas. So you have 1,000 transactions here, you can process in 1 second, right? So you publish on chain, this can be verified instantly. So in this way, they're trying to scale. So I'll also publish the code, working code here. So, you can do it on Ethereum, but also you can do it on Bitcoin. Basically, we implement the so-called zero knowledge on Bitcoin. So you can, after you generate the proof here, you can also put it on Bitcoin. And because our layer 1, right, the consensus layer is more performant. So even if this is true, you can scale on Ethereum. So the funny thing is it actually can work on Bitcoin and works better because think about it, right? So let's say you can verify proof, one proof every second on Ethereum, but because our base layer is more performant, we can verify 1,000, 10,000, even 1 minute. So whatever you do here, technology actually works much, much better on Bitcoin. And we have already published code in smart contract. This is not something they're planning. So they are planning to roll this up maybe in the next 5 years, but you can already do it on Bitcoin today. So just another good example of, you don't have to launch a new blockchain for anytime you have some new ideas. You can just code this in smart contract on Bitcoin natively. Okay. Any feedback here? Roll up. Okay. Okay. That's good. Let's keep going. I think at the come to the last example I want to give. So this is almost like a sibling of Zcash called Monero. So just and again another hand raising round. So how many people heard about this cryptocurrency Monero before?
I heard.
Yeah.
Okay. Yeah, it's the biggest. Usually we talk about the Zcash and Monero. So this also uses a technology called mostly. It has a few technology underpinnings, and one of the major ones called ring signature. This is also I think it's a good idea and kind of elegant. So in normal Bitcoin signature, right, easy to say, if you have a public key, and then if you want to sign against it, so there's only one prior key you can sign. That's valid, right? So, even though the address, is not linked to identity, but maybe sometimes you reuse, right? So it can have some implications. Sometimes if you're not careful, you can leak your privacy. So what that ring signature idea is also very simple. So instead of having one private key that can sign, you can have multiple private keys that can sign, right? So for example, you have 11 people here, they form a so-called, circle, which is why it's called ring signature. So the way is, any of the 11 people, anybody who's in the ring, he can sign. And then the signature is going to be valid. So in this way, what it means is, if you only look at the signature on chain, even though it's coming from this set of people, but you don't know exactly who signed this exactly, right? So the idea is hide in the crowd, right? So instead of look at the public key and then you link it to somebody, you kind of like form a ring with, let's say, 100 other people. So if any of them sign, it's going to be valid. So you don't know, then you're hide in the crowd, right? So the bigger the ring, the more difficult it is to track down who actually signed this. So again, this is also like a cryptography algorithm, and it's again based on elliptic curve. So again, it's almost the same idea we had before when we implement the Schnorr signature. So instead of either introduce a new opcode or even launch a full independent blockchain, you can actually duplicate the same functionality by coding a smart contract to implement the ring signatures here. So this ring signature, when you publish the smart contract, anybody who's within the ring, they can sign and take the money. You don't have to use Monero even in this sense. You can actually run Monero on top of Bitcoin. Let's say you issue some token called Monero token, right? So you combine it with this contract. So within this contract, anytime you're checking whether somebody is authorized to transfer some Monero tokens, you're going to check the ring signature instead of checking the normal ECDSA signature. Make sense here?
I have a question. I'm not familiar with ring signatures, so how does it work? So any of these people can spend this money, or actually only one of them can spend, but it will be indistinguishable from other spending his money?
Oh, any one of this can, any one of this can spend the money. If you, let's say, okay, even go back one step. So in short summary, what is ring signature? Basically, let's say you have 10 public keys that form a ring. So if you use ring signature, anyone who knows any of the private key for these 10 public keys, when they sign, and then they compare with it, almost you have almost like you have a group public key. So if you form a ring, you can have a group public key, and any of these people in a ring they can sign against this group public key, and then it's going to be deemed valid. Anybody who is outside of the ring, you cannot generate a valid signature. So back to your question specifically, if your contract says, hey, whoever can generate a valid signature against this ring public aggregate public key can spend the money, and then any of the people in the ring can spend the money. But you can also use other combined with other logic.
So we effectively can treat this ring as one financial entity just with several people connected to it, right?
Yes, yeah, you can be formally any way. The ring is you decide who's going to be in the ring.
So, for example, if someone in this ring will spend his money on something illegal, they all be effectively responsible. And if we can track like the ring, it doesn't matter who of them actually was doing this stuff. And I don't see how it makes the network anonymous.
Oh, it's not fully anonymous. Basically, think about it's almost like a mixer. So if you think about it that way, so
It's like
any of this
plausible deniability, isn't it?
Yeah, you don't know which one exactly. You know this group of people. It's not fully anonymous, so it's just more. It's more private. It's not
But
fully.
they have to form a trusted circle between each other because anyone can spend their money, yes?
Yes, but from outside, you don't know which one, right? From
but
inside, you know one of them, but you don't know just from a signature. Look at signature. There's no way you can figure out who signed exactly. You know one of them, but you don't know which one.
Yeah, but what I actually mean by that is if it's like small circle of trusted people who can spend each other's money, from the legal perspective, they all can be sued and they cannot hide by each other in the crowd.
Yes, that's what why the mixers are being taken down. Yes, I'm talking about technology, tech side of things. But legally, yes, I think there's some laws about mixing. If you don't know which one, probably all of them have to be responsible in some way. So that's why for all this kind of currency, Zcash or Monero to be adopted, more people have to use it, because if you hire just two people, right? If the range is just two, it's not much additional privacy you gain, right? But what if you have 20,000 people, right? So it's just yeah, you add more privacy, but as you said, legally speaking, that's another story. You probably all of them, if you use any, that's another reason I think this is not going to, in my opinion, never going to gain mainstream adoption, because no merchant can take this money.
And how even theoretically is it possible to 20,000 people having access to the same amount of money and not even one of them like run away with that money?
Oh, that's one thing. It's just you can. This is just one primitive, right? So you can have. It's not like anybody in Monero can spend any money, right? So again, this is just one primitive. You can also says, hey, maybe it's almost like you can always think about it like a mixer, right? So, for example, you say, oh, if you deposit one, you have end up having one Monero in the first place, and then you put it in a ring, and then you can only withdraw one Monero token outside of the ring. So you can have additional mechanism to. This is only one to have the ring, to have the group membership, but you can have built more logic on top of this to make sure not everybody can spend everybody else's money. This is one component for Monero. I'm not saying this is the full thing. That's the only thing Monero does. So you add more functionality on top of this to make sure other constraints are not violated.
So to summarize my understanding, so in Mixer they rely on central authority to solve this problem, and in Monero they solve it somehow in decentralized way, right?
Yeah, you can think about this. Yes.
Okay, thanks.
Thank you. And also you have a more advanced version, which is called Tornado Cache. So they also got a mixer. So the thing is, the ring does not have, it can be dynamic. You don't have to be No, at the beginning. So anybody who's sending the ether into the Tornado smart contract, Tornado Cash, then you are like join the ring. It's dynamic. For here, the native ring signature is you have to know all the members in advance. You form a ring, but there are also more advanced cryptography, which is using zero knowledge. You can have a dynamic ring, so you can join anytime. You can also leave anytime. Yeah, for people who's interested in knowing more.
Yes, thanks.
Thank you. Yeah, good question. Any other comments, things?
Yeah, one question on my side. So the difference between ring signature and if I use an HD wallet is that I will have several private keys for each individual and then the same public key for all of them. And if I use an HD wallet, I have different pairs of private and public keys. Will that be the difference? I'm not sure if
yeah, HD wallet, usually you have only one owner, right? But here, usually we talk about multiple owners, multiple people.
Yeah, but the same with an HD wallet, you could provide the pair of private key and public key to different people, right? And
oh yeah, but in that case, still, right? If you have one public key, the person who knows the private key can sign, have a valid signature. But in this case, is you have let's say you have 10 public keys, then each of any of the 10 people can sign. But which is different from HD, right? HD is just you can have multiple pairs, but for each pair, specific pair, only one private key can generate a valid signature. Does this?
As far as HD wallet forms hierarchical structure with only one key, and ring signature is not hierarchical; it's flat.
Yeah, it's not. It's not like all of these are peers you can think of, right? So HD wallet, right? You can have a master private key, but here's saying, right? When you sign specific key, public key, you have to generate the corresponding private key, right, from the master private key. The bottom line is, even you use HD for one public key, there's only one private key you can sign that can generate a valid signature. But for this ring signature scheme is, anybody who is in the ring, you can generate a valid signature. So you think about that, only a ring size of one, right? But here you can have multiple people in the same ring. For HD, you can only have, ring size is one. If you can, that's another way to think about it.
yeah, thanks.
Thank you.
So could you use this in something like some messaging system like Twitter or something where
that's
like Tal, and when they make announcements or when anyone who can answer can just sign it,
that's what the people are trying to do it in some kind of like a whistleblower way, if you want
exactly.
Okay. People are using this technology too. Yes, to hide in the crowd. Yes.
Ooh.
Okay, I think that's good enough for today. Any other comments, questions?
So is all the code snippets you showed us part of a library then that we can use? Or...
Yes. So I think if you go to our GitHub, there's a repo called the boilerplate. So basically, you can go to sql.io. So at the bottom, there's a GitHub logo. You click. All the code I've just talked about is in the boilerplate, and you can also find all the explanations in our blog, Medium or medium.com. So all the code and the explanations there. If you want to know the details, I think I'm going to, at the end of the full course, I'm going to walk through some of the most famous examples there. But you can also, feel free to browse around our repo and also blog right now.
Okay. Yeah. Thanks.
Okay, thank you. Anything else? All right. If not, we can call it a week, and hopefully see you next week. Okay. we'll get into the
Yep.
more the hands-on side of the course. Okay.
Excellent.
Thank you, guys.
Yeah, thanks
All
a
right.
lot.
Enjoy the rest of the evening.
Thanks.
Okay.
Awesome.
See you next week.
Thank you.
Okay. Bye-bye. Thank you.
Bye-bye.
Cheers.
Bye.
Bye-bye.